Welcome to today's ArXiv CS Digest for April 13th, 2026. We received 830 new computer science papers today across 60 subfields. Let's dive into the top picks. Trend 1 of 5, Generative AI for Visual Data. This trend explores generative AI for creating, editing, and enhancing diverse visual data, spanning 2D graphics, 3D scenes, and videos. This cluster covers 214 papers. Representative work includes who handles orientation, investigating invariance in feature matching, pair to scene, learning local object relations for procedural scene generation, and omni-show, unifying multimodal conditions for human-object interaction video generation. Trend 2 of 5, LLM understanding and evaluation. This trend explores how to make LLMs understand, reason, and be evaluated more effectively across diverse tasks and data. This cluster covers 203 papers. Representative work includes SAR voice, a multi-speaker Saarbrücken dialect speech corpus, psychological concept neurons, neural control bias probing and shift generation in LLMs, and CLSGen, a dual-head fine-tuning framework for joint probabilistic classification and verbalized explanation. Trend 3 of 5, AI for system enhancement and security. Leveraging AI to enhance system performance, bolster security, and optimize human-AI interaction across diverse applications. This cluster covers 101 papers. Representative work includes enhancing program repair with specification guidance and intermediate behavioral signals, identifying inductive biases for robot co-design, and retrieval is not enough. Why organizational AI needs epistemic infrastructure. Trend 4 of 5, physics-informed AI and system analysis. AI leverages physical principles and simulations to analyze, predict, and control complex systems. This cluster covers 217 papers. Representative work includes physics-informed state space models for reliable solar irradiance, forecasting, and off-grid systems, solving physics Olympiad via reinforcement learning on physics simulators, and physics-informed AI accelerated retention analysis of ferroelectric vertical NAND, from day-scale TCD to second-scale surrogate model. Trend 5 of 5, developing and securing AI agents. These papers unify research on the full spectrum of creating, evaluating, improving capabilities, and safeguarding diverse AI agents for reliable and safe operation. This cluster covers 95 papers. Representative work includes detecting safety violations across many agent traces, incremental data-driven policy synthesis via game abstractions, and CausalGaze, a runtime security framework for tool-augmented LLM agents against indirect prompt injection. Up next, our first paper out of 5, How Alignment Routes, Localizing, Scaling, and Controlling Policy Circuits in Language Models by Gregory N. Frank from Independent Researcher. Let's break down its key contributions. This paper identifies a sparse routing mechanism in alignment-trained LLMs, comprising a gate attention head that detects content and amplifier heads that boost refusal signals. This mechanism is foundational to understanding policy enforcement. The gate head's causal necessity is established through interchange tests, while amplifier heads demonstrate stability via bootstrap resampling. This rigorous validation confirms the mechanism's critical role in policy routing across models. The study analyzes how the routing mechanism distributes at scale and demonstrates continuous control over policy strength by modulating the detection layer signal. This allows fine-grained steering from refusal to factual compliance. The paper investigates the mechanism's robustness using cipher encoding, revealing a structural separation between intent recognition and policy routing. This identifies specific conditions under which alignment policies can be bypassed. Up next, our second paper out of 5, Learning When Not to Learn, Risk-Sensitive Abstention in Bandits with Unbounded Rewards by Sarah Lau and Benjamin Plott from Harvard University. Let's break down its key contributions. This work formalizes a novel two-action contextual bandit model, incorporating an explicit abstain option for environments with unbounded negative rewards. This model addresses high-stakes scenarios where a mentor is unavailable, enabling safer sequential decision-making. We propose a caution-based algorithm designed to learn when not to commit, prioritizing safety over aggressive exploration. This approach ensures that the agent avoids actions that could lead to irreparable damage in high-stakes environments. The algorithm constructs a dynamic trusted region, committing only when available evidence does not certify harm. This mechanism enables cautious exploration, preventing catastrophic errors by abstaining from actions in uncertain or risky contexts. Up next, our third paper out of 5, $Lambda_, a typed Lambda calculus for LLM agent composition by Qin Liu from Nanjing University. Let's break down its key contributions. This contribution defines Lambda, a typed Lambda calculus for LLM agent composition. It introduces 11-term formers, a type system, and operational semantics, providing a formal foundation to analyze. Up next, our fourth paper out of 5, CausalGaze, Unveiling Hallucinations via Counterfactual Graph Intervention in Large Language Models by Linggang Kong and Yao Pan for National University of Defense Technology. Let's break down its key contributions. Models LLMs internal states as dynamic causal graphs, representing the flow of information and influence. This provides a structured understanding of model computations. Employs counterfactual interventions on the causal graph to isolate true causal reasoning paths. This helps to disentangle genuine signals from incidental noise and spurious correlations. Integrates causal graph modeling and interventions into a novel framework, CausalGaze, for hallucination detection. This shifts from passive observation to active causal inference for improved accuracy. Up next, our fifth paper out of 5, Hodoscope, Unsupervised Monitoring for AI Misbehaviors by Ziqian Zhong and Aditi Raghunathan from Carnegie Mellon University. Let's break down its key contributions. The paper introduces a novel formulation of unsupervised monitoring, drawing an analogy to unsupervised learning. This approach aims to discover problematic agent behaviors without prior assumptions about what constitutes a misbehavior. It leverages group-wise behavioral differences as the primary signal for detecting anomalies. Problematic behaviors are identified by their distinctiveness when comparing action patterns across different groups or contexts. The Hodoscope tool operationalizes this insight by comparing behavior distributions across various agent groups. This systematic comparison identifies statistically significant divergences in action patterns between groups. Hodoscope highlights distinctive and potentially suspicious action patterns for human review. This mechanism focuses human attention on the most anomalous behaviors, significantly reducing review effort compared to naive sampling. That's all for today's AR14 CS Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries. See you tomorrow.